Bismillahirrahmanirrahim. So this is a small clip on the Fourier series, and this is related to one of the last class assignments, which will be given to you, sent to you over the WhatsApp, and will be uploaded on the website. Uh, so you have to watch this clip and then work on the class assignment. And the Fourier series, it is the lecture related to the Fourier series is lecture number 6 on the website. So for details you can also look at the lecture number 6. Now where do we use Fourier series? What is the application of Fourier series? The main application of the Fourier series is to look at the frequency components or the frequency content of a signal. Uh, and basically for a periodic signal. So Fourier series, this is the difference between the Fourier series and the Fourier transform. Both of them convert the time domain signal into the frequency domain signal. So, but Fourier series is for the periodic signal. And Fourier transform is for non-periodic or aperiodic signals. So let us look at and both of them they give us the spectrum or the frequency component. So basically what is the transformation, what is the application of these two tools is the transformation from the time domain to the frequency domain. What are the periodic signals? Periodic signals are the signals which repeat themselves. So this is an example of a periodic signal, and so on. So if this is 0, this is 1, this is 2, this is 3. So this signal repeats after every 2 seconds. So this is the time of repetition is called the time period. And the fundamental frequency is defined as, so this is T0 is the time period, and the fundamental frequency of the signal is F0, which is equal to 1 over T0, or omega naught, which is equal to 2 pi by T0. So this is in radians per second, and this is in hertz. This is in hertz and this is in radian per second. So this is an example of a periodic signal. And an example of a non-repeating signal or non-periodic signal or aperiodic signal is just a rectangular pulse. So this is an aperiodic signal. So for this one, for transformation of this signal from time to frequency, we need the Fourier transform. And to transform this signal into the frequency domain or the spectrum, to find the spectral components of a periodic signal, we use the Fourier series. Now, what is Fourier series? What do we do? What is the application of Fourier series? Fourier series is basically we have a periodic signal. So I have a system, an LTI system. I have an LTI system, linear time invariant system, and the input of the signal is a periodic signal. The input is like a, so this is 0, this is, maybe I can, so the period in this case, the period is 1, and the fundamental frequency omega naught, which is called the fundamental frequency, is 2 pi divided by t naught. So the Fourier series allows us to find the to split this signal in terms of frequencies. So what I essentially do is, if the frequency of this is omega naught, or f naught or omega naught, let us just stick to the radian. So if the frequency is omega naught, then the first harmonic is its fundamental. So in the Fourier series, we split this, or so the Fourier series allows us to split this into harmonics, which means that if we write the Fourier series, we will be able to uh, transform this or split this into some of these harmonics. The first harmonic will be the fundamental frequency, which is omega naught, and with an amplitude of A. The second will be the faster one, the double the frequency, so it will be twice as fast as the fundamental, and the amplitude, another amplitude, which is B plus triple, so 3 omega naught, and plus 4 omega naught, plus 5 omega naught, and so on. Now the Fourier series allows us to split any periodic signal into these summation of the harmonics. So what is the advantage of this in terms of finding the output? The advantage is we can, as it's like the concept is analogous to the convolution concept. In convolution, what we did, we splitted the signal into time domain. So I had delta t here, and for delta t I can find the impulse response. So this is an impulse, I can find the impulse response. So if I have any other function x of t, I can just evaluate the output in time domain. So I can write the convolution integral, so I can evaluate everything in time domain. Now in the Fourier series, in the Fourier domain or the frequency domain, we know that it is much easier to find the output of a sine or a cosine signal. So if I have a cosine signal or a sine signal with a frequency, the output will also be the same frequency, but with a different amplitude. So for example, here it is C. So if the input is 2 omega naught, the output is also 2 omega naught with another amplitude. And if the input is 3 omega naught cosine, the output is also 3 omega naught cosine with another amplitude. So now the output will be just the y of f in this case, y of omega in this case, will be just a summation of all these functions. So c of omega naught plus d of omega naught plus e of omega naught, all these functions. So this is the amplitude, and this is I just call the functions at c dash, d dash, and e dash, and these will be c dash, e dash, d dash, and e dash. So this is it's, it's a way to find the output. So if we can split the input into the harmonics, it will be easier to find the output by adding the output corresponding to each harmonic. So this is one of the advantage of Fourier series. Now let us do solve an example which will clear the concept of Fourier series. So basically our job is to write any function, any periodic function in terms of its Fourier series. So let us look at an example which is also from the lecture number 6 on the website. Now this example is a rectangular function, a series, a periodic function which is a combination of rectangular pulses. So it is like this, and this is negative here, this is 0, this is -1, this is +1, and so on. So I have, this is the period. So the period in this case is, this is 1, and this is 2, this is -1. So the period is 2, as we can see here. This is 1. So this is the time domain. The period is 2. So I can just use it. I can use, this is 1 period. Now the Fourier series has 2 steps to find. The first part is called the analysis, in which we find the AK, which is the amplitudes of the sine and cosine signals. So AK is defined as 1 over T naught, and I integrate it over 1 period, x of t e raised to the power minus j k omega naught t dt. And the second part is called the synthesis part, in which we write it in the form of series. So x of t is equal to summation of all these AKs to infinity, AK e raised to the power j k omega naught t. So these are the 2 steps in finding the Fourier series. So let us find the Fourier series of this function here. The first step is to find the time period. So the time period is, the first step is to find the time period. So time period is T naught. In this case it is -1 plus 1. So it is equal to 1 plus 1, sorry, 1 plus 1. So it is equal to 2. And omega naught is equal to 2 pi over 2, which is equal to pi in this case. Now second step is to find the AK. So AK is equal to 1 time period, x of t e raised to the power minus j k omega naught t dt. So I have 2 integrals, so one from -1 to 0, and then the second from 0 to 1. It is easy, it is better to find this, to split the signal into symmetric over 0 and then find the integral. So here we split it into from -1 to 0 and 0 to 1. So there will be 2 integrals. The first one is from -1 to 0, and it is negative, and then e raised to the power minus j k omega naught t dt plus 0 to 1. This is 1, so it will be just e raised to the power j minus j k omega naught t dt, and this will be just negative will come outside, e raised to the power minus j k omega naught t divided by minus, so this will become plus, divided by minus minus j k omega naught. Well, this is a negative sign here, so it will eventually become plus, it will be e raised to minus j k omega naught t from 0 to 1. This is from minus 1 to 0, and this will be divided by minus j k omega naught. So this is equal to ak is equal to, this becomes plus, so it will be 1 over j k omega naught is pi. I can put pi here, and I can put 0 first and then 1. So when I put 0 here, it will be 1 minus e raised to the power, when I put here minus 1, it will be j k omega naught, and omega naught is pi, so I can just replace it by pi, plus minus 1 over j k pi. I put 1 here, so it will be e raised to the power minus j k pi and minus 1. So it will be equal to, I can add the two, j k pi, 1 minus e raised to the power j k pi minus e raised to the power minus j k pi plus 1. So this is equal to 1 over j k pi, 2 minus I can take as a common factor, and also I can this is, if you can look at here, this is a cosine, right? The only thing missing from the cosine is 2, so I can just divide it by 2 and multiply by 2. So this is my cosine of k pi. So this is equal to 1 over j k pi actually we forgot something here. There is a t naught here, so 1 over t naught, 1 over t naught, and t naught is 2, so I can just put it here, 1 over 2, 1 over 2, and then there is a 2 here, a 2 here, a 2 here, and a 2 here. So this 2 will get cancel, and then inside it will be, this will be cosine k pi. So this is my ak. So this is ak equal to 1 over j k pi 1 minus cosine k pi. Now I can see that if I put 0 here, a0 will go to infinity. So that's why we cannot use it for a0. So a0 we have to find it separately from this integral. So from this integral, a0 is equal to 1 over t naught. I just put k equal to 0 here. So it will be x of t dt, which means that this is an area inside the period. So this is area of x of t in one period divided by t naught. Now in this case, the area is, if you can look at here, over one period, the area is 0 because this is minus and this is plus, and they have the same area. So this area in this case is equal to 0 in our case here. So now I have all the values. I have a naught and I have ak for all the values, and then I can find sum of these, because the Fourier series has the summation is infinite, so but I cannot find the infinite values. I can just find some of them, and then the other ones I can just assume, or if I find some, I know how can I determine the others very easily. So let us first look at some of these AKs, starting from 0 and then plus minus 1, plus minus 2, plus minus 3, and so on. So now what I will do here is I will delete this one here. Let me delete here, and let me just calculate. So A naught is equal to 0, A1 is equal to 1 minus cosine k pi. So it will be, let us start from A minus 1. So A minus 1 will be 1 over minus j pi 1 minus cosine minus pi. So this will be equal to 1 minus cosine minus pi is 2. So this will be minus 2 over j pi. A plus 1 is equal to 1 over j pi 1 minus cosine minus pi, and that will be just equal to 2 over j pi. A minus 2 is equal to, if I put here minus 2 pi, the answer will be 1 minus 1, 0. So this is 0. And A minus plus 2 will also be 0. A minus 3 will be minus 1 over 3 j pi minus 1 over j pi 3 and 1 plus 1. So this will be minus 2 over j pi 3. And A minus 3 will be 2 over j pi 3. A4 will be 0, and A plus 4 will also be 0. A minus 5 will be minus 2 over j pi 5, and A plus 5 will be equal to 2 over j pi 5, and so on. So these will continue to infinity, but now we know the trend. We know that we just need to replace the k with the number, and this will be 2. Always, this will be always 2 for the odd numbers, and for the even numbers it will be 0. So this is, now I can find all these AKs. The last step is now to write down the summation of the series. So I can delete this here. So x of t will be, this is the last step, which is called the synthesis, step 3. So x of t will be equal to summation of k equal to minus infinity plus infinity ak e raised to j k omega naught t. So I can start from minus infinity, and then the first value will be, I can do any one. I can start from 7. So I know that 7 is 7 pi e raised to the power j 5 omega j minus j 7 omega naught t. Omega naught is pi, so I can just put pi here. Pi t, or omega naught, whatever. So omega naught equal to pi, as we found in the first step, minus 2 over minus 0, because a6 will be 0. So this is a7, a minus 7. This is a minus 6, minus 2 over j 5 pi e raised to power minus j 5 pi t. This is a minus 5. Then again 0. Then minus 2 over j 3 pi e raised to minus j 3 pi t. then again 0, and then minus 2 over j pi e raised to power minus j pi t. This is a minus 1, and this is a minus 3. And now a0, which is 0, and then I go to the positive values. So I start from here, 2 over j pi e raised to power j omega naught, which is pi t, plus 2 over j 3 pi e raised to power j 3 pi t, plus 2 over j 5 pi e raised to power j 5 pi t, and so on. Now I can see that I can combine these two. I can combine e raised to power j pi and e raised to power minus j pi, and one of them is positive and one of them is negative. So let us do this combination. So I can come starting from a1. So 2 over j pi e raised to power j pi t minus e raised to power minus j pi t. All right. So this is actually sign, because 2j, if we have positive minus negative exponential divided by 2j, the answer is sine. So I can write all these plus 2 over j 3 pi e raised to the power j 3 pi t minus e raised to the power minus j 3 pi t plus 2 over j 5 pi e raised to the power plus j 5 pi t minus e raised to the power minus j 5 pi t, and so on. So this will be, and then this is goes to infinity. So I can write here or I can just write it here. This I already know. So I can just, so this is my x of t actually. This is the summation x of t. So I can write here x of t equal to, so this is sine. I can bring this j inside and another 2. So I have to divide it by 2. I have to multiply it by 2. So this will be basically 4. So 4 over pi sine pi t plus 4 over 3 pi sine 3 pi t plus 4 over 3 pi 5 pi sine 5 pi t, and so on. So this is my Fourier series. So if I combine, if I add all these values until infinity, I will get the square wave. So this is called, it is a sine series, because if we add these, the two ak plus k and minus k, the answer is sine. So I call this as sine series. Now in the class assignment, I will like you to follow these steps and do the same problem, write down. So it is very easy, just write it down, all these steps for the same example, and submit it with the I will give it to you actually in writing, and then you can submit it to me in the before the second midterm, before the first midterm. And there will be another example. I will also put it in the website, or I will put it in the class assignment and then give it to you. That will be the example 2, and that is an example of a cosine series in which I have, this will be my signal. So this is 0 and this is 2. So I have the same time period. So t naught will also be equal to 2 in this case, and omega naught will be 2 pi by 2, which is pi again. But the answer of this will be, if you do all these steps, it will be a cosine series. And you can get help from the, this question is actually available many places. It is also available in the problem set. So you can look at that and follow the steps and give me the submit the assignment.